Hi folks, welcome back. I hope you're all doing well. Today I want to take a look at a paper which looks at a system which performs end-to-end repair of software in a real-world production software engineering environment. I've covered on this channel some other papers which talk about automatic patch generation, and this paper builds on a lot of the ideas from that previous work but takes it one step further by implementing those techniques in a production setting with a real and large software engineering organization. The authors are from Facebook, and this system, which they call SapFix, was actually deployed in Facebook to create and submit patches to their production system. The goal of such a system is to automatically find bugs in code that has been proposed for review and submission, and then go ahead and also propose fixes to those bugs. One of the key techniques that this builds on is the ability to test these incoming patches, because that is what triggers the entire sequence. The end-to-end workflow at a high level is fairly intuitive and straightforward. You start with an incoming patch and you run that patch through a large test suite. And if you find that the patch crashes or fails a bunch of tests, you then trigger creating a fix for that patch. Now, SapFix can use one of 4 alternative strategies to fix the patch. You could either fully revert the patch, you could partially revert the patch, or you could use one of 2 strategies to generate a fix for the patch. The 2 strategies that SapFix works with are template-based fixes or mutation-based fixes. Now, like I said, I've covered some previous papers on patch generation which cover some of these techniques. Now, as I said, a key technique that this entire thing rests on is automated testing, and that is true of this proposed fixing patch as well. This patch that fixes the buggy incoming patch is then once again pushed through a suite of automated tests. If multiple proposed patches pass all the tests, then the authors use a predefined priority based on the patch generation strategy, and they prefer template-based fixes to mutation fixes, for example. And then they pick one patch that passes all the tests and send that for review to the original author of the incoming patch. And then the reviewer has several choices. They can either accept this suggested patch as is, or they can reject it, or they can suggest changes to it and submit the fix with those changes. Within their mutation-based strategy, the authors focus on fixing null pointer exception bugs. And the reason is very simple. It is because NPEs account for more than 50% of all crashes. So how did this system fare in real life? What the authors found was that they had about 57 crashes that they were trying to fix. And to fix those, they constructed about 165 patches. Roughly half of them were using the template-based approach, and the other half were using the mutation-based approach. Out of those, 131 built and passed the test suites, which is a surprisingly high fraction, I think. And 55 of those were sent for review to the developers. As I mentioned here, anecdotally, most initial reactions from developers were quite positive. About half of the fixes proposed were judged to correctly fix the underlying failure. And within those half, about half were accepted as is without any changes, and the other half were modified by the developer themselves. Interestingly, of the ones that were modified, only half were actually edited by the developers, while the other half got to the developer after they themselves had fixed the bug. Now, as we saw, one of the strategies that SapFix has is to revert a diff if it is causing too many test failures. However, every time SapFix tried to do this, those reverts were declined by the developers, which is not surprising because developers aren't too happy about reverting their hard work on their patches. So what can we learn from this deployment experience? I think the key lesson is that end-to-end automated repair can work within an industrial software engineering organization. About a quarter of the patches proposed by the system landed into production and were accepted as is, with another quarter that were correct but were not landed for other reasons. This is a pretty high hit rate for a fully automated system. The authors close with several thoughts for future work, but one of the ones I found most interesting was that developers often wanted to communicate with the bot that was proposing these patches, even though they knew that it was a bot on the other side. What this indicates is that there is an interesting line of work to investigate a dialogue between the repair tool and the developer. So that was a quick look at SapFix, which is a system to create patches to fix bugs end-to-end fully automatically in a large industrial software engineering setting. I hope you found that interesting, and I will see you next time. Thank you very much.